Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So you will see a video lecture series on semiconductor diodes and their applications. So the first topic here is the PN junction. So in this video, we will see about the formation of a PN junction diode. So PN junction diode is one of the semiconductor devices. So semiconductors are materials whose conductivity lies between the conductors and insulators. So semiconductors are classified as intrinsic and extrinsic. So extrinsic semiconductors are further classified as P-type and N-type. So a PN junction is an interface or a boundary between two semiconductor materials. So namely the P-type and the N-type inside a semiconductor. So in a semiconductor, the PN junction is created by the method of doping. So the P side or the positive side of the semiconductor has an excess of holes and the N side has excess of electrons. So the process of doping is explained in the next slide. So the PN junction diode is one of the semiconductor device with two semiconductor materials in physical contact, one with the excess of holes and the other with the excess of electrons. So we can take a single crystal of intrinsic semiconductor and we'll be doping one side of it with the positive and other side with the negative. So it is we'll be doping it with the acceptor impurities and the donor impurities. So such junctions can form the basis of very efficient rectifiers. The most important characteristics of PN junction is the ability to allow the flow of current in only one direction. So in the opposite direction, it offers very high resistance. So the high vacuum diode has largely been replaced by silicon and selenium rectifiers. These are some of the applications of PN junction semiconductor diodes. So it is used in power supplies, optoelectronics, instrumentation, radio and television, industrial electronics, computers, etc. So in a piece of semiconductor material, if one half is doped by the p-type impurity and the other half is doped by the n-type impurity, a PN junction is formed. So the plane dividing the two halves or zones is called as the PN junction. So the n-type has high concentration of free electrons while the p-type material has high concentration of holes. So therefore at the junction there is a tendency for the free electrons to diffuse over the p side and holes to n side. This process is called diffusion. So this diagram shows that so the p-type, the majority carriers will be holes and the minority carriers will be electrons. So there will be less number of electrons and more number of holes, whereas in the n-type number of electrons will be high and the number of holes will be small because it is the minority carrier. So when the free electrons diffuses from the n side to the p side, an ionized donor is left behind on the n side, which is immobile. As the process goes on, a layer of positive charge is developed on the n side of the junction. Similarly, when a hole goes from the p side to the n side, an ionized acceptor is left behind on the p side, resulting in the formation of a layer of negative charge in the p side of the junction. This region of positive charge and negative charge on either side of the junction is termed as the depletion region. So, the net negative charge on the p side prevents further diffusion of the electrons into the p side, and the net positive charge on the n side repels the holes crossing the p side to the n side. So, a barrier is set up near the junction which prevents the further movement of charge carriers. Due to this positive space charge region on either side of the junction, an electric field with the direction from a positive charge towards a negative charge is developed Due to this electric field, an electron on the p side of the junction moves to the n side of the junction. This motion is termed as the drift. So here we see that the direction of the drift current is opposite to that of the diffusion current. So because of this induced electric field, you will be getting the electrostatic potential difference which is established between the P and N regions. Because of this, we have a barrier which is known as the potential barrier, junction barrier, diffusion potential, or the contact potential. So the magnitude of the contact potential varies with the doping levels and the temperatures. The electrostatic field across the junction caused by the positively charged n-type region tend to drive the holes away from the junction, and the negatively charged p-type region tends to drive the electrons away from the junction. So this majority holes diffusing out of the p region leave behind the negatively charged acceptor atoms bound to the lattice, thus exposing a negative space charge in the previously neutral region. Similarly, a positively space charge will be created by the n region, and a double space charge layer builds up at the junction. So it is noticed that the space charge layers are of opposite sign to the majority carriers diffusing into them, which tends to reduce the diffusion rate. So thus the double space of the layer causes an electric field to be set up across the junction directed from N to P regions, which is in such a direction to inhibit diffusion of majority electrons and holes. Hope you understood how the PN junction is formed. So let us take up some assessment questions. Diodes can be used in making of, the choices are rectifiers, LED lamps, logic gates, all of the above. The answer is all of the above. A diode is the simplest of the semiconductor device, has a characteristics that closely follows that of the switch, is a two-terminal device, all of the above. Yes, a diode satisfies all these three. In a PN junction with no external voltage, the electric field between the acceptor and the donor ion is called as the options are peak, barrier, threshold, and path. As the answer is barrier potential. Thank you for watching this video.